Yep.
Okay.
Good guys. Good guys. Am I gonna go to straight view?
Okay, guys.
I would. You might as well. It's closer.
Only to refresh, guys. Only to refresh. Batman and Robin.
Go ahead.
The secret in the refrigeration cycle is the refrigerant, of course, no? Because the refrigerant in some part of the cycle absorb heat, in other part release heat. Where absorb? In the evaporator, inside. And outside release heat, no? And the compression of the refrigerant because the compressor. The compressor is the heart of the system. If the compressor fails, if the compressor is working so-so, the compression of the refrigerant is not enough, and you don't have the cycle. It's simple. An element that damage the compressor. What is the enemy of the compressor? Water, moisture. Moisture is number one. And remember that the compressor internally is a piston, you remember? It's a piston that is moving, and that piston is moved by a motor, double phase motor, you remember? 2 windings. And you need current in both windings, you remember? Run and start in both windings. If you don't have that current in both windings, the motor start? Nope. No. The motor needs current in both windings. That's the only way to start the motor. And the current, guys, follow me. The current in both windings should be heavy current, because that system is hermetic, is closed, with pressure in both sides. No, the system is pressurized. You think that it's easy for that compressor to start at the beginning? No, it's heavy because both outputs are pressurized. It's hard for that piston start at the beginning. For that reason, at the beginning, the system used 2 capacitors. You remember? Two capacitors together to jump it. Immediately the compressor start to move, the start capacitor disconnect and continue running only with wrong capacitor. I'm going to check if it's possible today, if not on Thursday, the wiring diagram, and we are going to analyze how is the process to analyze the air conditioning units. Okay. In normal conditions, at ambient temperature, the refrigerant is vapor, no? Because it's boiling. It's boiling at minus 22 degrees Fahrenheit. At ambient temperature, is boiling, of course. It's vapor. In other words, in the suction side of the compressor, the refrigerant enters vapor. Immediately, it's compressed and goes out of the compressor vapor, but with high pressure and high temperature. And a couple of inches later, start to condensate, to become liquid. And liquid, and enter in the capillary pipe, or what is the other name for the capillary pipe?
Expansion valve.
Expansion valve. When the refrigerant enter in the capillary pipes, enter liquid, high pressure, high temperature, pass through the capillaries, and in the output is liquid, but with low pressure and low temperature. It's practically frozen, no? But it's liquid, and enter in the evaporator, and start to evaporate. Start to suction heat, absorb heat, evaporate, and in the output of the evaporator is completely evaporated, the refrigerant, and enter again in the compressor, vapor, completely evaporated. That's the cycle. Good, no?
If you have high pressure in the low pressure side, what's it?
If you have high pressure in the low pressure side, no, it's not possible.
No?
No, it's not possible. No, that's the regulation of the expansion
But what would
valve.
be an issue? The expansion valve's bad? Or?
Yeah, probably. Normally, problems related with the expansion valve, I forget mention, in marine application, the expansion valve, the preferred expansion valve, is the capillary pipe. In industrial application, in residential applications, they use, instead of capillary, they use a valve, thermal valve. The valve open and close depending of other factors like pressure and temperature. I am going to explain later. It's the thermal expansion valve. It's a nice design. is used, in marine application, they prefer a lot of capillary pipes, except in chiller systems. Next week, I am going to explain chiller systems, and I explain the thermal expansion valve. But in the rest of the air condition is the capillary pipes. The capillary pipes use the principle of Bernoulli. You have this diameter, and suddenly it's reduced to this diameter. The pressure and the temperature decrease dramatically, dramatically, in between this and this. That's the situation. Okay, guys. Normally, in the typical air conditioning unit, like this, the air condition of your home, the coil that you have inside, is the evaporator. And that coil, if you touch the pipes of that coil, inside coil, those pipes are frozen. No? And if the air filter is clogged, what happened? No air circulate through those coils frozen, and ice is created and block that radiator, the indoor radiator, the indoor coil. The outdoor coil is hot all the time. If you touch those pipes, are too hot. Yeah, the fan around those pipes in your home is to keep the temperature of the refrigerant a little low, to protect the pipes, and to help the refrigerant to reach the expansion valve at the proper pressure and temperature. You remember what is the pressure and temperature that is necessary before the refrigerant enters in the expansion valve?
180.
The pressure is around 180 to 20, and the temperature is around 110 degrees Fahrenheit, you remember? And in the other side, the pressure decreased for 70 psi and 40 degrees Fahrenheit, something like this. No? That delta in pressure and temperature is constant. For that reason, it's important the cooling system in the condenser. In your car is with air, in your home is with air, in your boat is with raw water. No? If you have lack of raw water, what is the symptom? High pressure and high temperature in the high pressure side. And what happened with the high pressure switch? Open and turn off the compressor, because you have lack of raw water. My air conditioning unit start, work a couple of minutes, and stop suddenly. Excuse me, can you start the air conditioning unit again? And can you check the raw water outside of your boat? Oh, it's not raw water coming out. Okay, that's the problem. You have a problem. Probably that coil is clogged, or the raw water pump is not working, it's broken, or the valve is closed. Some technician during the service close the valve and never start again, never open again. That's very, 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 very common for entry-level technicians. And of course, if the pump, the raw water pump, is running without water, bingo, finito. That raw water pump is expensive. The raw water pump for air conditioning unit, this one. This is the raw water. That's the input, and this is the output. Look at the diameter of the input, and look at the diameter of the output. High pressure, no?
You can't just use a normal water pump? Like the ones they use for the fresh water?
No, because this one receives the power from the computer of the control unit, and it's AC. If you put other raw water pump, mechanical raw water pump, is that one works. Excuse me, follow me. This raw water pump works together with the compressor. When the compressor starts, the raw water pump starts at the same time. And it should be, this is single phase. This is 110, 120, 50 hertz, 60 hertz. What is the meaning of that? You can use that one with American power or European power, doesn't matter. That's okay? But this pump receives the power from the circuit that activate the compressor. At the same time that the compressor starts, this pump starts. I am going to explain the process. Okay, guys, pay attention to this. You know that there are some air conditioning units with this element. And this element, this valve, this is this valve. One input here and three outputs. Three-way valve or reversing cycle valve. Reversing cycle valve or three-way valve. Follow me this explanation, my friend, because this is very, very, very important. You know that in your air condition, you can select cooling mode, blue color, or heating mode, red color. In your car, you can select red or blue, cool or too hot. In your home, also, in the thermostat, you can select low temperature, cooling mode, or high temperature, heating mode. In winter, in some places, you work the air conditioning unit in the heating mode. In summer, you work the air condition in the cooling mode. Okay. Pay attention. In the summer, I wanted that the air coming out through the evaporator be cool air, cooling mode. But in the summer, I prefer that the air coming out here be hot air, because the temperature, the ambient temperature is frozen. I want hot air in my home. This is the heating mode. What do you think if I select heating mode? Normally in cooling mode, when I touch those pipes, the pipes are frozen, no? Practically with ice around. When the air passes around those pipes, I receive cold air. In the heating mode, I suppose that those pipes are too hot. No? And of course, I suppose that the pipes of the condenser coil will be frozen because the system is opposite. When I select heating mode, those pipes are too hot. When the ambient air, cold air, pass over there, and I receive hot air. Wow. In that case, with that valve, I convert the indoor coil in condenser and the outdoor coil in evaporator. When I select heating mode. I select cooling mode, the indoor coil is evaporator and the outdoor coil is condenser. Everybody follow me?
Would that mean liquid still coming through the compressor?
I am going to
No, it's not.
It's gonna be hot.
to change the flow of the refrigerant. Pay attention. In normal conditions, in cooling mode, in the discharge port of the compressor, you remember high pressure and high temperature, immediately after that become liquid in the condenser, the condenser is too hot. What happened if the output of the compressor enter not in the outdoor coil? The discharge of the compressor with high pressure and high temperature enter in the bottom of the evaporator are too hot, and when the air pass over there, I receive hot air. I am going to reverse the cycle. I am going to pass the refrigerant for number one, not for the outdoor coil, for the indoor coil, and after that finish in the outdoor coil. In other words, I am going to heat the indoor coil and I am going to cool the outdoor coil. Everybody follow me?
Do you just skip the
Yeah,
condenser?
pay attention. This is possible with this valve. With this valve. I'm going to explain that valve in details slow because it's a little difficult to understand that concept.
So are you still going through the condenser outside, or you don't go through that?
You
just
don't
skip
need
that?
move nothing. The only that you need is move the selector
No,
in
I'm
the
saying like,
thermostat.
does the refrigerant still go through the outdoor condenser, or it just goes like from the compressor to the evaporator immediately?
Immediate. No go.
Through the out.
Okay, follow me. I am going to select in my air condition unit. I am going to select, this is the reversing side. Yeah. I am going to select cooling mode. The typical cooling mode. I am going to select cooling mode. Alright, in cooling mode, normally the discharge of the compressor, red color with high pressure and high temperature, go into the outdoor coil. This is the outdoor coil. Okay, and this is the raw water, no guys? Look at the raw water. The raw water enter here, pass through the filter, enter over there, circulate through the coil, and goes out raw water. Okay, good. This is the outdoor coil, and this is the indoor coil. Okay, normally the high pressure, vapor, high pressure, go here, high pressure, high temperature, go here, and now this metallic element is closing this and this. What happened? Continue here, and start the process of cooling, and become liquid, continue liquid over there, and now in the other side is liquid, and enter liquid here and start to evaporate and goes vapor, and enter in the compressor. Yes or no? This is the typical cooling mode. In this moment I select cooling mode. Good. Okay.
The high pressure switch is right there after the condenser, right?
The high pressure switch normally is here. And you connect the red hose of the set-off gauge here. And the low pressure switch is here. Excuse me, this is the feeding, sorry. This is the feeding, and this one is the feeding for low pressure, no? Mm-hmm. And you can connect the high pressure switch in any part of this, normally here or here also, no? You can connect the high pressure switch here. Because this is high pressure. Anybody follow me? Okay, guys. No, I wanted to change for heating mode. And I am going to select in my thermostat high temperature or heating mode. What happened? I have a solenoid here. Immediately I change to heating mode. The thermostat sent a signal, and that signal enter here and move it. This is a solenoid, and move it this piece of metal here. Pay attention. I am going to move it this piece of metal right now here. Now it's here, before was here. Now it's here. Anybody follow me? Guys?
Yes.
loop.
Okay, guys. Okay, guys, pay attention. The compressor is the same, the discharge port and the return port. Right now, the discharge, high pressure, high temperature, not goes here, goes over there, because I moved the piece of metal. Everybody follow me? And now the vapor, high pressure, high temperature, high pressure, high temperature, high pressure, high temperature, enter here. Yeah? And what happened? It starts to become liquid. And now liquid here, liquid here, liquid here, liquid here, liquid here. Until the expansion valve. After the expansion valve is liquid, 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 and start to evaporate here. Yeah? And what happened? Enter vapor, 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 vapor here, and return vapor, vapor, vapor in the compressor. And now, what happens in the indoor coil? When I start that blower, the blower suction the air here, and what about the air that I have here?
It's gonna be warm, right?
Hot air. Oh, wow! This is the reversing cycle.
How do you get it cold outside?
Excuse me, that raw water is too cold.
So how does it go from liquid to vapor?
Where is liquid to
Wouldn't
vapor?
it be liquid all the way? How does it become vapor in an outdoor coil?
Pay attention. Here is liquid with low pressure and low temperature. However, a couple of inches later, it starts to evaporate because it's surrounded for the environment.
Pressure, yeah.
My friends, this is the cooling and heating mode. And the secret is this solenoid. This solenoid. You see, guys? One input in the button and 3 outputs. Depending where is positioned the piece of metal, the vapor goes here or the vapor goes here. Exactly like I explained over there. And this is possible because this solenoid, you see the solenoid? That solenoid works with the AC current. It's not DC. That solenoid is AC, and the current is in between 20 and 28 volts AC. When the coil receives the power, I'm going to explain the diagram in details. Immediately the magnet moves the metallic element inside of this. I have other one broken with the metal, but I didn't find.
If those solenoids go bad, you have to replace.
Okay,
You have to, like, cut
pay
them.
attention. It's very common that this solenoid be damaged. For example, here in Florida. Because here in Florida, practically we never use the heating mode. Sporadically, 1 or 2 days per year. Yes or no? And when you decide to use the heating mode, the solenoid is and no works. It's very, very common. For that reason, the people say, I don't want to replace my air conditioning unit. Oh, I want to replace the unit for a new one, but with no heating mode. Because I don't use the heating mode. It's less expensive.
Then you wouldn't have to fix it.
To fix it, no, you need cut the pipes and replace that stupid pipe.
If they're replacing it with one that doesn't have a heating mode, why don't they put it in a heating
No.
mode?
This.
Factory, bro.
So can you still use it if the solenoid's broken, stuck on cold, and you don't care about the heating, you just want to keep using it? So you can just use it?
Yeah. For that reason, the people here in for example, in Florida, or in warm areas, they prefer order the air conditioning unit only with cooling mode, and it's less expensive. No, I don't know, Mr. Porter, in your home over there, heating mode.
Better have it.
Yeah. How much?
45 on Thursday.
What temperature are in the winter? What is the temperature? The lower temperature.
It's up freezing.
Oh wow.
I burned wood.
Yeah. All right. You like the explanation about the heating mode and cooling mode?
Mm-hmm.
Nice, no? Nice. This is the reversing valve. Okay. Now I am going to add it. The electrical portion, and we are going to analyze the wiring diagram. My friend, I need that you follow the videos of the next coming chapters today and tomorrow. Tomorrow we don't have class. We are going to cancel the class. We are going to continue on Thursday. Okay, if everything is okay. But I need that you follow the videos. Follow the videos because I cannot advance here if you don't check the videos.
So you want 7 and 8?
Yeah, I'm going to open all of them. Okay, let me. We are going to take a couple of minutes PP break. I complete the picture and we analyze the wiring diagram.
I don't understand how we return from vapor here. Because it's outside, but it's raw water. But it's being cooled by water.
Once it gets like to the outside environment,
It just instantly just vapors up because how hot it is outside. But then you should even have your raw water pump going. Man. Mr. Lopez, when you reverse it to heat, do you still have your raw water pump going? But what would be the point if you're...
It's better. It's better. Some people turn off the pump, but it's better.
But it runs with the compressor, so it's gonna like...
Always
It's
it's
gonna
running
be
because the
running.
compressor starts the pump.
Right,
'cause
right.
I've seen some though where on the DC panel or the AC panel it'll have the separate AC water pump.
I don't like that. I prefer that
They're
the
together.
computer of the air conditioning unit start the pump. No you.
What, you saying like on a breaker? You
Yeah.
turn on a
Yeah,
breaker?
separate
Wow.
breaker. That's not good.
It sounds like something they just slapped
It's a Mickey
together.
Mouse on his car.
Probably the original one broke, or like it's like a house. Install a fucking water pump on it.
Mm-hmm. That's why they use the freshwater pump system.
Yeah. Dude, I will say I feel like we're gonna be dialed in on this, and we can actually because it's not like we're working on any. What's that?
Shit talker.
What?
Cameron's a shit talker. He likes to talk shit.
Huh?
He likes to talk shit.
I left at 6:30 in the morning, and I got up to Georgia at 1.
So you parking teacher parking now?
Yeah.
Like 1 o'clock.
Gangster
My car's on its last life anyway. It's on its last life.
Four-wheel drive. Four-wheel drive. That's the only thing that if you have a go, teach it.
Last time you did it before, but now I see it. Like if I didn't know you.
Oh, yeah. Yeah. What do you want? Chevy Silverado, Colorado. The first truck I was going to get was a Colorado.
You looking at trucks too, bro? I've been looking at so many trucks lately.
Oh, that's too expensive.
No, I'm looking at used. Okay, I'm not buying new. I'm looking at used trucks from like 2010.
I can't. I prefer going to a dealership and like paying a little bit.
For what? But what year? The new one?
Yeah, but no, because I feel like it's just gonna break down too much.
I don't know. That's why you gotta know which one you're getting.
You
I've
gotta-
been
you
watching
gotta- you
videos. I mean, V8 only, bro.
You're going for a V8? He was
I
telling me about this website called HCrack.
H- H. Craig.
And they got a bunch of
Let me see.
nice trucks. HCrack.com.
Because at first I was looking at, I looked at a bunch of dealers. I wanted to see what they had private sale first, offer Facebook Marketplace.
But like most of them is 40K.
That's factory.
Yeah, I mean that's used or new. That's used. With how many miles? Like 30?
This is 2018.
Even still, 40K for 7,000 miles.
4-wheel drive.
Yeah, I'm looking at 4-wheel drive.
64,000.
Cab, 4-wheel drive.
64,000.
You see, this is brand new. Is buying a brand new. That's the same thing as buying brand new.
I don't like this one. Either I would go for either a Ford or a Ram. I like Ram.
I like the Silverado. I hear
Those are expensive though.
Ford too, bro.
Air your tires, you probably just
They look nice though, I'm not gonna lie.
I like the Silverado. Cause I was looking at a bunch of diesels, but right now diesel ain't prices around. Them shits are expensive. But you can find diesel for 30 grand. Diesel?
But like, how much is like, let's say, how much are we gonna spend on a weekly? Like
On
weekly?
gas?
Yeah, gas.
And tanks, I said to the one I was looking at had like 35 gallon tank. That's like almost 200 bucks to fill it up.
Oh yeah, they're huge.
Almost 200 bucks to fill it up. That'd kill my pocket too. And the one I drive.
My girlfriend will show me.
Yeah.
Yeah, most of them, like from what I've seen, is just they range from either 30 to 40K.
But you know, you want like, I want the crew cab, the double doors with the big seat from the back.
Yeah, no, I don't want it, like, I want it to be spacious in the back.
Yeah, that's the crew cab.
Dude.
That's the same.
I had an uncle, and I would get him
They're like, yeah,
it's a no.
that's like the crew cab.
I hate it. Look,
I've been looking.
Hold on, man.
Yeah, I see. Yeah, I'm on Silverados right now. I like Silverados, but you know, I need a 4x4 to cool stuff.
Yeah, that's what Tyler was trying to. It's better to get a 4x4.
Yeah, cause if you're trying to let the boat down in the ramble, you need that 4x4. I don't want my fucking car I paid for to go in the water.
I prefer it. I mean, if you're gonna go full out, might as well just go full out. It's better to save money, you know.
That's all it is. Shit,
But it's
just
expensive.
so expensive, yeah.
Sucks.
Yep.
But definitely, I think it's worth it because like a truck you could use for everything. Like you're moving,
Yeah, you're always gonna use a truck.
they're always gonna call you. Everybody's always gonna be calling you.
Yeah, like I need your help to move shit. The 4-wheel drive makes it more expensive.
I like the new Rams.
Fisher, what's up? Like everything I see here is fucking 2-wheel drive.
I saw one that was 4-wheel drive. It looks like a Ford one though. I feel like the place you go is Miami.
Yeah, right. Miami is where you get overcharged. You go more up north.
Bro, my family, they know this Hispanic place where they got the best trucks. Like, they got some good trucks.
Hispanic place, they got the best trucks.
It's a dealership. No, dude, everybody goes there. Like, literally everybody. It's like a Cuban place. It's like a bomb. forgot the last name of those people.
Man,
They can get some match, but you gotta remember what.
and you know from the dealers you're gonna get all those fees added, at least like six grand. What? No, coffee. That's all you know how to do, Cameron. All you know how to do. Exactly. I've been looking at trucks bro for
Or
I'm buying used, I ain't buying new.
No, I know,
It's too
but, like,
expensive.
you
But
don't
it's
care about
between, I don't know, I really want the Chevy. Silverado. Yeah. 'Cause I don't
Silverados
like
are
the
nice,
Ram.
but
My
they look
dad
like
has
little
the Ram.
boxes.
I don't like the Ram. My dad has one, and
It depends on the year. I like the newer ones.
I mean, but I'm trying to buy used underneath like 25 grand. That's all gonna be like 2010 around there
Not really. You can find like a 2015.
for 25 grand. I don't know.
You want four-wheel drive?
Two cabs, 4-wheel drive.
6 on it?
8 preferably.
Diesel or gas?
No, I looked at a bunch of diesels. You can't really find any diesels for around 25 grand. I seen like one that had like 200,000 miles on it. Yeah, he just told me about that. So, yeah.
I mean, I like it, but it's like as is. It's like they sell it as is. So like, if, you know how like if you go to a dealership,
There's no warranty.
yeah, there's no warranty. If there's something that's like a little broken, they can't do anything about it. So I mean, it's cheaper, but like for my truck, I turned it on there and it sounded fine. I went home and I turned it on and it had cam phaser rattle. Like the cam phasers do rattle.
See that new Ram? A new Ram?
Yeah, the new ones are sick. I don't like the hood on it. So like that's something that
Yeah, you gotta
can't do
take
shit
it.
about.
Yeah, that's why sometimes it's better to buy at a dealer so you get the warranty and stuff like that.
Depends on like truck. Like sometimes it's better just to buy an older truck. Pay $800
That's why. I was looking at private sale. I was looking at a bunch on private sale first,
I never heard of that.
like off-road, like
yeah.
people selling their cars instead of through
It's
dealers.
always these fucking like Spanish people that put it on and then it's like $5,000 and oh shit, and you look down, it's like this is a down payment price.
No, yeah, I've seen a bunch of those.
Shit.
I've seen a bunch of those.
And then you ask them a question about it and they're like contact me, call me. And I'm like, I'm not fucking calling you.
I've seen a bunch of those.
I heard Carvana's good, man.
They deliver your car, which I don't like because you can't see it.
You know, you go there to the thing and it comes down on the elevator or whatever.
Yeah.
Like I seen this one, Like prior to? Only tell me, they tell me the after, and it's not a 4x4.
It's not 4x4.
I know, don't even. But it's nice.
It's a nice.
He kept it well maintained, it looks like.
One of the biggest things for me was the 4x4. There were so many good deals I found for like 2-wheel drive.
Yeah.
I was tempted getting a 2-wheel drive.
What do you have again?
4-wheel drive.
But what's your car?
Ford.
What is
Ford
it?
F-150. It's good. I mean, it's not like the best. It's like a basic.
Yeah, whatever.
Model.
So,
Just gets the job done.
yeah, the XLTs are comfortable.
Yeah, but it has like the bucket seats, which I don't like.
What do you mean?
The bucket seats. It's like, so instead of having like push to your, when you're driving to your right, it's a seat.
Oh, the
So
one that you
it's-
come up
yeah.
and down? Yeah,
It's good for when you're like, you know,
With
in a
another
car with a girl.
you want to get
Exactly. But like,
Yeah.
when you're like, for like.
Wait, that's not a problem for you, though.
No, but the back, you see the back of it?
Uh,
The back, the seats fold up. So
Yeah,
you
they
have so
do.
much space. You do anything.
I know those things are comfortable, man. Cause
That's how much I liked it. When I saw the back seat, I recorded it. Let me show you.
It's not like you can do anything. You gotta wait till fucking there.
Okay, look.
Damn, why you exposing everyone out here?
Okay, guys, come on.
Yeah, those. I keep my strap right under there.
Dude, that man has so much space.
Yeah. I seen this one post. This guy's like, I made a custom like bed for the bed.
Oh,
Like a custom mattress for the bed.
So like,
You know he's fucking that shit. My brother probably nut all over it.
you gotta get a blue light.
Yeah. He's like, oh hell no.
Okay, guys, I need your concentration here, please. We are going to analyze what happened.
How does that look like that?
I don't know, dude.
Nothing, bro. You don't know nothing.
My mom makes leather concealed, like,
Golf shoes?
yeah, if you ever want one.
I've never carried leather. Supposedly they're comfortable.
Yeah, it's definitely not for comfortability, it's for looks. Like, you want
Yeah.
that old school leather, like,
Nah, I'm all
it's
about
not the
my
comfortable,
technique.
like, that concealed, like, plastic one.
Like Kydex shit.
Right.
Yeah, the main thing for me is just not being able to pull my trigger to the bottom. 11 hours ago, I didn't check Marketplace today. But that one's nice. Is this dealers? Yeah, like, hold on. It probably says down here.
115,000 miles.
Bro, on the truck.
Okay, guys.
Well taken care of.
How do you
Please,
how do you know
please,
it's well taken
please,
care of?
please,
You,
gotta look at the
you
Carfax.
owned it?
You gotta look at
I need
the
concentration in this diagram because this is the entire system. That's the system complete, guys. Okay, we have the AC panel here. The breaker, hot and neutral. Hot enter in the breaker. Everybody follow me?
Yes.
And the neutral goes back. My friends, if you understand that one, install the air condition. In next class I'm going to explain the procedure to install. It's too simple, but the diagnosis, if you understand this, you don't have any problem in the future. Okay, guys. One of the breakers in the AC panel is air condition. AC unit. When you activate that breaker, the power enters here, hot and neutral, coming from the breaker, in that control box. Immediately, the power enters, the power pass for the triac. The triac is a diode with two outputs. If the signal coming from the look, the thermostat enters the signal in the circuit board, and the circuit board sends other signal to activate the triac, to close the contact in the triac, and the current here pass for here and pass for here. That's okay? If the triac is open because the thermostat is off, no current. Everybody follow me? The triac open and close depending of the signal coming from
The thermostat.
the triac. Triac.
You can still have the thermostat on, but no cooling or heating, right? If it's just on, is it gonna open?
In the thermostat, you select the cooling or heating.
But let's say you just turn it on just to like read temperature without
No, no,
putting
no.
heating or cooling.
You turn it on the thermostat.
Uh-huh.
It's on. But until you select
The
temperature,
yeah.
the system start or not.
Uh-huh. So if you
That-
turn it on, it's not gonna pass power to the
No,
triac, right?
no, until you select the
The
proper
temperature.
temperature. Okay, guys, please. I have 120 volts here. Yeah, because it's coming from the breaker. When the triac close the contact, I have 120. This is the high pressure switch. The high pressure switch is a normally closed switch. If the pressure in the high pressure side of the system is normal, the current pass from here to here, and the current continue here and enter in the thermal switch of the compressor. You remember? And I have current in this point. If the body of the compressor, the housing of the compressor, the temperature is good, the current pass through the second one and enter in the common terminal. Enter in the common terminal here of this relay. This is the motor relay or compressor relay. Follow me? This is the motor relay or compressor relay, and now I have power in the middle of the relay, in the top one. I don't have power here and I don't have power here. At the same time, the relay sends current for here and also sends current for this relay. This block, this small block, is the system relay. System relay is the relay of the complete system, the entire system. It's other relay. We have two relays. One relay in the motor of the compressor and other relay in the control box for the system. Anybody follow me? Okay. In that relay, I have the current entering in one corner. That relay have other corner with neutrals. Those neutrals are coming from the neutral bus bar of the AC panel. That corner is for neutrals. Look at the corner for neutrals. You see that corner for neutrals? White color coming from the neutral bus bar of the AC panel. Okay, I have neutral here and I have 120 volts here. Follow me. After that point, I have a resistor. And the resistor, of course, reduces the voltage a little. Probably here I have 107. And that current enters in this capacitor, in the wrong capacitor. And also I have neutral in this capacitor and I have neutral in this capacitor. Remember that to charge the capacitor, I need neutral and hot to charge the capacitor. No? I need neutral and hot. Okay, I have the neutral here, entering here, and also entering here. And also that neutral enters in one of those terminals. But I need the other one with good power to start the compressor. Yes or no? Okay. I have neutral, and I have the first power. When the current enters here, the voltage decreases a little and enter here and saturate that capacitor, the wrong capacitor. And the capacitor absorbs energy. At the same time, when the current is here, the current here internally in this system relay is located other thermal contactor. This is a thermal contactor. Okay, the thermal contactor normally is closed. The current pass here and saturate the start relay. When this relay is saturated and this relay is saturated, you have extra current from this plus this current. You have double current here, enter here, double current over there, neutral, and current in the common, the compressor starts. Immediately the compressor starts, this thermal contactor opens. And this capacitor is disconnected, and the system continues running only with the run capacitor, and the compressor continues running. And this is the wiring diagram.
The power coming out of the start capacitor goes back.
Pay attention. At the beginning, when the current enters here in this corner, the current is divided in two. One here and other here to saturate that one. When this one is saturated, return extra current here, and you have a jumper in this one. You have this plus this. Nyan, nyan, and now you have double current here. The compressor starts. When the compressor starts, this current is disconnected, and you have only that one. And the motor continues running with the run capacity.
And there's diodes from the triac to the relay, to the system relay.
Here in this triac you have diodes. In the relay you don't have diodes. That's the relay. The current enters in one corner, pass through the other one to saturate this capacitor. This one saturates the start capacitor. When both of them are saturated, send the current to the compressor. After that, this one is disconnected, and the system continues running only with this. Exactly that. You want that I repeat again, step by step? No? Let me repeat again. But it's clear, my friends? You like it or not?
The low pressure switch.
Excuse me?
Forgot the low pressure switch.
This is the circuit board, no? This is the circuit board. My friend, this is the system completely. Once again, I'm going to start the air conditioning unit. To start an air conditioning unit, I need two elements. One element is the main breaker, no? Main breaker. Okay, I have power in the breaker. When I activate the breaker, immediately the air conditioning unit starts?
No.
No, I need to activate what other element?
Thermostat.
The thermostat. When you select the temperature, the thermostat sends the signal to the computer, and the computer verifies with this sensor located in front of the filter what is the ambient air entering, passing in front of the sensor. With this temperature and the temperature that you select, the computer do the comparison and send that signal, the blue signal, to the triac and activate the current here and here. Clear? For that reason, in all the computers, you have those three data terminals. You see? Those three data terminals. One data terminal is to connect
The thermostat.
the thermostat. Other one to connect
The temperature.
the sensor. And other one to send power to the triac. Nice, no?
For the ones in the boats that have the humidity control, what's different on the sensor that senses the humidity control?
No, it's another sensor. It's another sensor. Normally, it's also located here, but that sensor have a hygroscopic substance internally and sense the level of humidity in that substance.
It just kicks it on for how
Yeah.
long.
Correct.
Yeah, so like when you leave like some of these boats, like when you leave it, you leave the AC switches on, and then you put on humidity.
The humidity
So
control.
it's just
Yeah.
a humidifier, really, or dehumidifier.
Only to absorb moisture.
So what does it do? Just take that moisture and keep it out?
Yeah, take the moisture and that sensor is heated. Is heated to evaporate that moisture. Like a dryer. I am going to explain in the next class that point specifically.
What were those two boxes right there on the high pressure line coming off the
Okay.
compressor?
In the high pressure side, you have one feeding. Thank you for the question. This is the gauge. This is the gauge. For high pressure. And this is the gauge for low pressure. Yes or not? And you have, of course, one hose red color for high pressure in the feeding of high pressure. And you have another hose low pressure
Would you search up on
Low
marketplace
pressure.
to find that truck?
for the feeding of low pressure.
2019
Anybody follow me? Guys, one hose low pressure in the low pressure side, other hose high pressure in the high pressure side. And you have another hose in the middle. When you connect the cylinder, the recovery cylinder, you have the valve, and you have another hose, yellow color, in the middle to recover or recharge refrigerant. Good? Okay. Pretty close to the feeding, in any part of the high pressure side, you can install the high pressure switch. Look at the high pressure switch. It's here. It's in the high pressure line. This is the high pressure feeding, and this is the high pressure switch. High pressure switch and high pressure feeding. In other air conditioned units, they have in the low pressure side, they have a low pressure switch. Other units only have high pressure switch. That one only have high pressure switch. We have another ones over there with high and low.
Do you have high pressure switches in the low pressure side? There is, right?
No. If you have a switch in the low pressure side, it's a low pressure
Low
switch.
pressure. Let's say
If you have other switch in the high pressure, excuse me?
there is high pressure in the low pressure side, and you didn't turn on the blower.
No. When you have reversing cycle, the majority of the units they have switch in both sides. Yeah. Okay, guys. Let me explain something additional. The circuit board,
The blower was
The circuit board here.
The blower. And it says there's high pressure in the low pressure side.
they have different output signals. In the circuit board, you have a couple of, hey my friend, you follow me or the cell phone, please? You have a couple of these for the pump, the raw water pump. A couple of these for the blower. A couple of these for the Y valve. Yeah? If you check the computer, here you have Y valve, computer, blower, pump. Yeah? In the circuit board, you have a bar here with outputs. Of course, depending on the signal from the thermostat, the circuit board sends current to activate the raw water pump. The raw water pump located here. Yeah? Last point. Look, depending on the thermostat sends the signal for the blower in the evaporator. And the thermostat also sends the signal to activate here the Y valve for heating and cooling. Everybody understand? The secret is what temperature entered here from the thermostat. The thermostat do the comparison with this sensor and send the signal to activate the triac. and also internally send the signal to activate the pump, to activate the blower, or the Y valve if it's in heating or cooling mode. Suppose that you select heating mode, and the Y valve, you never hear that click on the solenoid of the Y valve. And of course, the Y valve never operates. You need to verify here what is the signal for valve. In that signal, the voltage should be in between 20 and 30 volts AC. You check neutral and this, nothing. Oh, that voltage coming from the circuit board is not going out. It's a problem in the circuit board. Normally, in the circuit boards, they have 3 fuses here. You need to verify those fuses. One of the fuses control the blower, other of the fuses control the raw water pump, and other of the fuses control the Y valve. You check the fuses or replace the fuses. My friend, that information, you never find a course like this on the street with that detail.
Where is the Y valve?
Mira, mírala. Mira.
It's a little bit I've seen, because in this outing, I was putting the gauge on the low pressure side and it was over pressure and it wasn't kicking on the blower. As you tried to turn on the AC, no blower, so there was high pressure in the low pressure side. When I released some of the pressure in the low pressure side, it turned on the blower.